So we've got two big products, or three massive products starting production next year. We've got Optimus, we've got Tesla Semi, and we've got the Cybercab.
The Tesla Semi is one of the three major products coming in 2026 that Elon Musk emphasized during the Tesla Shareholder Meeting event. Although it's a highly regarded vehicle, Elon Musk has rarely talked about the semi-truck lately, and there are three reasons for that. First, it's still in the testing phase. Its current specs, performance, and design are all prototype level, mainly for data collection. Second, Tesla still doesn't have a fully automated production line or a dedicated factory for the Semi. The total number of semi-trucks produced since 2017 is only around 300 units. Finally, the Tesla Semi still hasn't achieved what Elon Musk ultimately wants, a feature that could transform the entire trucking industry if successfully integrated: full self-driving. Yes, the big thing the Semi has been missing is full self-driving. However, Tesla has now solved all three of these issues for the newest version of the Semi. This will be the official production version rather than the current test prototype. It will be built entirely at the company's newly completed factory, making Musk's target of 50,000 trucks per year realistically achievable. Elon Musk has also revealed several major changes the Tesla team has made to the Gen 2 Semi to enable successful FSD integration. So what's new in this version? And how will the Tesla Semi convince truck drivers to make the switch? Let's get started.
We already have a lot of prototype Tesla Semis in operation. PepsiCo and other companies have been using the Tesla Semi for quite some time. But we will start volume production at our Northern Nevada factory in 2026.
This is Tesla's brand new factory built specifically for producing the electric semi-truck. As you can see, it could easily be considered a semi-gigafactory because of its massive scale. Previously, Tesla built the Semi almost entirely by hand, but with the new factory, production will shift to a fully automated assembly line. It's impressive that Tesla managed to put up such a huge facility in less than 2 years. And now we're getting our first look inside this new plant. With the new factory and automated production lines in place, Tesla says an annual capacity of 50,000 semi-trucks is completely achievable, giving them the ability to compete with the output of a traditional heavy-duty truck manufacturer. In the trucking sector specifically, Tesla's biggest competitor in the US is Peterbilt. They produce around 60,000 heavy-duty trucks every year at their Texas factory, and the company's total truck sales in the US and Canada reach roughly 300,000 units annually, a massive number that currently leaves Tesla far behind. Elon Musk is confident this new factory is a very solid first step toward making Tesla a formidable player in the heavy-duty truck market. But more importantly, the Tesla Semis that will come off this new production line will be somewhat different from what we've seen so far. Musk has been frank that the Semis already on the road, even those delivered to customers, are basically early prototypes. They're strategic test units Tesla has been using to gather real-world data and feedback. For that reason, the Semi's design has remained largely unchanged since its debut in 2017. Now it's time for a revolution. The Tesla Semi needs a comprehensive upgrade, not just to look more modern and futuristic, but most crucially, to reach its boldest goal: full autonomy. You heard that right. A Class 8 truck that can operate without a driver while still hauling cargo on public roads. The company revealed a refreshed design through a few limited images at the event. From what we can see, the headlights have been redesigned to match the new Model Y, Cybercab, and Cybertruck. The new light bar stretches across the front of the cabin, giving it a more modern, aerodynamic, and sleek appearance. Looking more closely, Tesla has also equipped the Semi with a new front bumper, while the roofline is now smoother and more rounded. Honestly, we really liked the headlights on the original Tesla Semi prototype. They looked like the truck's eyes, and the illumination was quite impressive, especially in nighttime footage of the Semi in operation. However, the new headlight design gives us the feeling that the updated Semi will look more futuristic and even cooler. Currently, the Tesla Semi achieves a drag coefficient of 0.36, a remarkably low number for a Class 8 truck. Tesla's decision to design the Semi inspired by Japan's #1 high-speed train helped it reach this figure. This is the key factor that allows the truck to accelerate from 0 to 60 miles per hour in just 20 seconds. With the upgraded version, this coefficient could be optimized even further. A drag coefficient of 0.34 is entirely feasible. This is no small matter. In fact, improving the drag coefficient by just 0.02 can reduce energy consumption by 5 to 7%, which translates to dozens of additional miles of range per charge. In contrast, Conventional diesel trucks typically have a drag coefficient ranging from 0.65 to 0.70, making them less efficient, more fuel-hungry, and louder due to wind noise. Thanks to its aerodynamic drag being roughly half the traditional standard, the Tesla Semi almost glides down the highway. What do you think of the Semi's new light bar design? In your opinion, which type of headlights would be more suitable? In the new upgraded version, another noticeable change is that the Tesla Semi's windshield has been shortened and set back less toward the rear of the cabin. At first glance, many might assume this is simply a cost-cutting measure by Tesla. However, in reality, it represents a significant step forward in both aerodynamics and safety. In the first generation, the Tesla Semi used an extremely large windshield, giving the driver an almost panoramic view. But if you look closely, the rear portion of that glass was almost unnecessary. At the same time, that rear section created considerable wind resistance at high speeds and added to production costs. So, Tesla likely redesigned the windshield, making it shorter while maintaining its full width. This design allows air to flow more smoothly over the surface, significantly reducing turbulent areas around the A-pillars. As a result, the overall drag coefficient is noticeably lowered. On top of that, the amount of direct sunlight entering the cabin is reduced, allowing the air conditioning system to operate more efficiently and easing the load on the battery pack. Okay, currently the Tesla Semi is using LFP batteries, but the new version has been confirmed to switch to 4680 cells. The advantages and drawbacks of using this type of battery in the Semi have already been made clear. As we all know, the 4680 is the best battery Tesla produces to date. It offers an impressive energy density of up to 300 watt-hours per kilogram, while also significantly reducing production costs thanks to its breakthrough structural design. But why do we say there are concerns about using 4680 cells in the Semi? It's quite simple. Unlike passenger cars, the Semi is a heavy-duty transport system that runs continuously, carries extremely high loads, and operates under much harsher conditions. Here, the biggest advantage of the 4680 lies in long-term performance. When you're hauling tens of thousands of pounds at high speeds, internal resistance and heat dissipation become critical factors. The tabless design of the 4680 helps reduce voltage drop, maintain more stable power output, and optimize energy efficiency over long journeys. This not only helps the Semi save electricity, but also maintain a steady speed on the highway, one of the key requirements in the transportation industry. But the downsides are also quite clear. The 4680 offers high energy density, but that comes with extremely stringent thermal management requirements. A Semi running at a total weight of 80,000 pounds is not like a Model Y driving around the city. The heat generated from continuous high current discharge puts significant strain on the cooling system. Tesla has had to redesign the entire pack, from the cell-to-chassis structure to the new generation liquid cooling system. In other words, if Tesla's optimization isn't precise enough, the battery could overheat, leading to reduced power when climbing hills or driving long distances at high speeds. This is the biggest risk of the 4680 in a heavy-duty environment. Another point that often goes unnoticed. While the 4680 helps reduce the overall weight of the pack, it also increases the stiffness of the vehicle frame when integrated directly into the chassis. This improves cornering ability, stability in crosswinds, and long-term structural durability. However, repairing or replacing the pack becomes more complicated and expensive since the battery and chassis essentially become a single, unified unit. You know, LFP batteries have proven their ability to handle continuous charge and discharge very well in industrial environments. The 4680, however, has not. So Tesla will need at least 1 to 2 years of real-world operation to demonstrate that the 4680 can withstand hundreds of thousands of kilometers of heavy-duty travel, high-intensity megawatt charging system use, and still maintain the expected stability. Tesla has also announced that the upgraded Semi now supports higher payloads, although they have not disclosed the exact figure. This opens up the possibility for fleets to transport more cargo per trip. The maximum allowable weight, including both the truck and its cargo, is currently 82,000 pounds. The ability to carry heavier loads also means the Semi's own weight can be further optimized. Specifically, the long-range Semi is currently confirmed to weigh around 23,000 pounds. With the new design and the 4680 battery pack, Tesla could potentially reduce the Semi's weight below 23,000 pounds. This design not only improves operational efficiency, but also increases driving range and optimizes the vehicle's cargo capacity. Another key improvement in the Tesla Semi Gen 2 directly relates to charging capability. The truck now supports a maximum power of up to 1.2 megawatts, far beyond the current megacharger capacity. When paired with compatible charging infrastructure, this allows fleets to significantly reduce charging downtime, thereby improving operational efficiency. Another very noticeable change in the new design is located just above the front wheel well. The black triangular shape protruding from the body clearly indicates a new camera mount. This quietly underscores the greatest potential of the Tesla Semi, a Class 8 truck capable of full self-driving without a human driver. While there are currently hundreds of electric trucks on the market across the US and Europe, none can fully drive themselves with a fully loaded trailer behind them. It seems Elon Musk is betting on a much bigger gamble for the Semi, a fully autonomous, zero-emission tractor that doesn't compromise driver longevity. Over the past year, some footage has shown the Tesla Semi testing FSD capabilities on highways. No results have been officially reported, but that doesn't mean Tesla has given up. The biggest advantage of pairing the Semi with FSD is stability and operational optimization. Humans get tired, robots don't. While traditional trucks must stop regularly due to regulations, a self-driving Semi could operate almost 24/7, stopping only for fast charging via the megawatt charger. This creates an entirely new transport cycle, with delivery speeds potentially many times faster than today and significantly lower shipping costs. Most importantly, it can assist human drivers on long-haul routes without compromising their health. However, deploying FSD on the Semi will certainly not be easy, both technically and legally. Simply put, rolling out FSD on a sedan or SUV like the Model Y already took several years of testing, and even today it still operates under supervised conditions. So, to achieve stable FSD operation on a Class 8 truck weighing 20,000 pounds and towing tens of thousands of pounds of cargo, Tesla must overcome a host of technical challenges that passenger cars never face. FSD on a semi-truck must anticipate farther ahead, make decisions earlier, and with much greater precision than a car. This is why FSD on the Semi could be Tesla's toughest test ever. When a passenger car makes a self-driving error, the risk is already significant. But when a Semi with a total weight of 80,000 pounds makes a mistake, it becomes a matter of national concern. That's why Tesla must demonstrate that FSD is not only good enough, but industrially reliable, capable of handling complex highway situations and emergency collision avoidance while carrying heavy loads. Dan Priestley, leading engineering and program development of the Tesla Semi, he wrote on X. The new front end, besides having a new look, is packed with improvements. More aerodynamic, simpler to build, easier to repair, leverages more components from car lineup for better scale/lower cost. More technical details on these to come. It's clear that Tesla is focusing on optimizing production costs for the second-generation Semi. The redesigned front end not only helps reduce aerodynamic drag, but also simplifies manufacturing and maintenance. Many components are now shared with other Tesla models, such as the Cybertruck and Model X, providing economies of scale, a key factor in reducing production costs while maintaining profit margins. As a result, although Tesla has not yet announced official pricing, experts predict that the Semi Gen 2 could fall in the range of $150,000 to $190,000, depending on configuration and driving range. This version is expected to be far more refined than the current prototype, from operational efficiency to cost optimization. For years, one of the most notable debates in the EV industry has been Bill Gates' stance on battery-powered heavy-duty trucks. Gates has publicly stated that electric trucks are not a practical solution. He argued that batteries would be too heavy, range too short, and operating costs too high for a Class 8 tractor to compete with traditional diesel. In Gates' view, a perspective shaped by decades in the software world, the energy landscape is fundamentally limited by battery energy density, and a fully electric Class 8 truck simply isn't feasible. But at that very moment, Elon Musk took the opposite stance, claiming that Bill Gates has no clue about electric vehicles. The launch of the Tesla Semi became, in a sense, a direct rebuttal to Gates' viewpoint. When the first Semi prototype appeared in 2017, many experts were skeptical. They saw it as yet another exaggerated promise from Elon Musk, either stock-pumping hype or a prototype that would never reach production. But once PepsiCo received the first Semis and long-haul routes began operating in the real world, the entire industry had to rethink what they previously believed was impossible. The turning point was the 500-mile full-load trip completed on a single charge. No reduced speeds, no lightened cargo, no special conditions. The Tesla Semi operated exactly like a Class 8 truck should: high speeds, maximum payload, and consistent energy consumption. This achievement directly challenged Gates's argument. Gates believed that batteries would need to be huge and twice as heavy to support long-range hauling, while Tesla proved that the solution isn't about oversized batteries. It's about optimizing the entire system from end to end. You know, it's no coincidence that governments in many countries support electric trucks. With electric trucks, the energy cost per mile is about 30% lower than diesel, depending on electricity prices and route conditions. Electric motors don't require engine oil, oil filter, changes, exhaust systems, turbos, complex transmissions, or the hundreds of moving parts found in a diesel engine. This dramatically reduces maintenance costs and minimizes downtime, making logistics operations more efficient and more predictable. On top of that, regenerative braking recovers kinetic energy and turns it into electricity, reducing wear on mechanical brakes and extending brake pad life by many times, a major cost factor for traditional fleets. Beyond cost savings, the energy efficiency of electric trucks is fundamentally superior. Electric motors operate at 65 to 85% efficiency, while diesel engines typically sit around 45 to 50%. This means every kilowatt-hour of electricity is used more effectively, producing stronger and more consistent torque. Heavy load acceleration, steady hill climbing, and maintaining high speeds are all areas where electric trucks excel. The low center of gravity, thanks to the battery pack mounted under the floor, also improves stability, reducing sway or instability that diesel trucks often experience in strong crosswinds. Finally, electric trucks offer clear environmental benefits. No emissions, and they help businesses meet increasingly strict environmental standards. In an industry that consumes an enormous amount of fuel, the arrival of electric trucks is not just a technological advancement, it represents a strategic transformation for the entire logistics sector. In theory, this means cleaner air, safer roads, and a more abundant supply of goods delivered at lower cost. If it becomes reality, it would be a massive leap forward. Production of the Tesla Semi at the new factory is reportedly on schedule to begin large-scale output in 2026, and it would be hard to argue that the Tesla Semi won't take over in the coming years. So, do you think electric Class 8 trucks like the Tesla Semi can really replace diesel in long-haul trucking? What impresses you the most about the Tesla Semi Gen 2? Drop a comment below. Thanks for watching, everyone. If you enjoyed this deep dive into the Tesla Semi and the future of electric trucking, make sure to hit that like button and subscribe. It really helps the channel grow. See you in the next one.